I'll let Simon do the honors, but first let's give him a very warm round of applause.
Can everybody hear me? Okay? Yeah? Okay, we're good. I'll see how I manage to not look at the screen. Speak up, like this. Okay. Can you guys see my mouse, by the way? Or is that too small? Okay. We'll see how that works. So anyway, I'm Simon from Masterchannel. I'm the CTO of the company, and I'm here to talk a little bit about how you sometimes need to be creative to solve a technological problem, especially if you're faced with an industry that's maybe not that pro what you're building. And I guess we've all come across the situation with AI that we're kind of at an intersection. One party is in favor of AI and it's all about innovation, and then there's other parties that obviously try to preserve the status quo, and they're very skeptical of what data you use for training and so on and so forth. So my goal today is to kind of show how we manage that challenge at Masterchannel, and how that challenge actually, I would argue, made us a better company in the end. So first of all, who are we? So we are the three co-founders, me obviously in the middle, and then the guy on the right, that's Christian. He's my business co-founder. So he probably knows even more about the legal and business aspects of what I'm talking about. I'm talking about it more from a technical perspective. And then we have Tom, who most of you maybe know as Matoma in Norway, who is our artistic co-founder, you could say. But my job is technology. I'm responsible for our tech stack, that everything's running. Also R&D that we do, how do we improve our models, and so on and so forth. But maybe first of all, the most important thing is, what do we actually do at Masterchannel? And the challenge is a bit hard to explain for people that don't come from the music industry, but I'll still try my best. If it's still unclear, please raise your hand and I'll try again. But essentially, if you listen to music these days, and you listen to the, I don't know, Taylor Swift's, Katy Perry's, and the big artists, there's usually a high production budget behind those songs you listen to, and no matter where you listen to that song, you're usually going to have a great experience. So those songs, as I said, they go through several talented engineers and a lot of studio personnel, and then they're being distributed to your streaming platform of choice, Spotify, whatnot. And then you listen to the music in different formats, on different systems. So that could be, your dad's hi-fi setup that he's very proud of. That could be you going for a run and listening on your AirPods. That could be you enjoying music on some better headphones. And then obviously the club or live venues are also a very important part of the music industry these days, because that's where a lot of revenue is being generated. So so far so good for the established artists, and the traditional production process that works really well, and that has been working well for decades. But now, obviously, everyone has a laptop at home, and anyone can produce music, right? Like if you wanted to start producing music today, you could just download a free digital audio workstation. You could, kick it off. But the problem is, once you actually distribute your music, you might be fine, if somebody listens to your music on AirPods, because AirPods are not notoriously known for having great sound quality. But then if you have a fan base that's maybe more audiophile, that have better headphones, or you want to show it off on a hi-fi system, or very importantly, you want to play it in the club, you might be met with very technical challenges, because your setup, as we see here, might not be the best, right? Like the headphones you use for producing music usually don't represent all the possible scenarios in which your music could be played back, and probably you're also not an audio engineer by trade. So it's a little bit like fishing in the dark. You don't really know what to optimize for. At the end of the day, you really just want to produce music. And this is where we come in, surprise. We fix that gap, right? And we inject ourselves into your production pipeline. So before you distribute music, you run your stuff through Masterchannel, and voila, you end up where all the other industry professionals ended up before. You can now rest assured that your music is going to sound great no matter where you play it back. So if you're a DJ and you play it in the club, there's no bass wave piercing people's eardrums or anything like that sort. You're going to be fine. So that's a technological problem we solve. Very technological, very audio heavy. But what does that look like from a customer perspective? Actually, very, very simple. You go to our website or to one of our partner websites, you upload your music, You see the different steps that the system runs through to optimize your music, and we'll get to how that works in a bit. And then after a couple of minutes, you get back an optimized version of your track, which you can then download and hopefully pay for. And we also give you some visual feedback on, okay, what actually happened to your music? How can you now be sure that what we output is actually better than what you uploaded in the first place? So yeah, so the question is obviously, how do you build such a system? How do you build a system that knows, okay, if I play this recording, it can be music, in the future it's probably also going to be podcasts and other stuff. If I play that back in the club, how's that going to translate? What stuff do I need to optimize to make that work? And then also, how do I learn? Like, what data can I use to train such a system? So maybe the naive idea you could come up with is, okay, I take a lot of poor sounding recordings, right? Like from amateurs, from your rapper next door who's working on his breakthrough album. And you also take a lot of great recordings from the industry and their archives, and then you just put some AI in the middle and then it's going to work, right? That's typically what people think happens behind the scenes. But spoiler, obviously, otherwise I wouldn't be standing here. That doesn't really work for many, many reasons. I can only scratch the surface. The most important reason, obviously, you don't really have access to that data. You could probably get away by trying to crowdsource some amateur data, but good luck trying to get professional records to train an AI system that is a competitor to the traditional way of doing things, right? You will soon run into problems. Nobody will want to give you their data to build a competitor to the established industry. Second of all, music is very diverse and it's constantly changing. If you have a data set, and let's say it's maybe large enough, which is questionable in itself, what do you do 5 years later? Now people listen to different music. Are you just going to do the same thing again, try to convince labels to give you their catalog and that stuff? It's not really a great experience. And then also, depending on the implementation, of course, you want to know what the model is doing, because what we're selling at the end of the day is peace of mind, right? Like, we give people the quality stamp. If you play this in the club, the audience is going to have a great time. If you have a black box model, as we learned with LLMs just now, for example, you can't have a glitch. Like, that doesn't really work in this context, especially if you have an industry where everyone is more or less against AI and very skeptical of what you're building. So that doesn't work. So we had to come up with something else. And the criteria were obviously, okay, we can't do any illegal training. We need to work with high quality data, and we need some transparency, and we need to understand what does the model actually do, and how does it get to where what the output actually sounds like in the end. And so the idea is actually pretty simple, and we've seen it in some other implementations before. The idea is to say, okay, I have limited amount of data maybe that I have access to. That could be our own music. That could be friends who like what we do, and they have a great catalog of music that we can use. And then you also kind of know, okay, maybe I have some ideas of...
It's okay.
We're good?
It's a door.
It's a door. Okay.
Not a mute.
And you might have an idea of, okay, for instance, the low end in the club is very important, because that's what is important to get people hooked and all that stuff. And so what we did, we just started mapping those different criteria out and trying to find implementations for those criteria that measure those different aspects, right? So if you input the signal into these, we call them scores, you get a score for, okay, how good is the low end response, or how well balanced are the dynamics? And you can repeat this for a lot of different aspects. So you get sort of a feature space of different functions. And now all you need to do is you input the signal into those feature functions and you get back a score, right? And now you're working in a space where you can say, okay, this score is independent from any data that I input to the system, because it's a mathematical implementation of a function. I can throw anything into that function and it's still going to work. I don't have to rely on the model memorizing certain things about the data I put into it for the score to work. And so that's essentially what we did, right? So we now have a model that operates not on the, let's say, raw data to raw data end, but we have a model that only looks at these different score implementations, and that understands, okay, if I see these scores and I see these problems, this is what I have to do. And the good news now is I can use artificial data to train this, because as I said, those score functions, it's just a function, it's hard-coded. You can put anything in there and you're going to get a score. You don't need to ask anyone for copyright permission or whatnot. And also one important thing is, this is going to work 5 years from now as well. Unless the acoustics of club venues change, we know, okay, this function is going to measure this aspect, and no matter if we produce hip-hop or some new genre we haven't heard of, that criterion is going to stay the same. So that's essentially the technology behind Masterchannel and how our system works. And it actually does work, yeah, that's very important. Maybe one aspect I haven't mentioned is that we can actually, behind the scenes, also see why a model made certain decisions, right? So if we see a model, I don't know, takes out 6 dB at 50 hertz, we understand, okay, why did that model make that decision? Instead of just looking at the output and philosophizing about, okay, why did it actually end up doing this, or why not? So as I said, the benefit is you can feed it any genre. It's pretty future-proof, and we now process 40,000, 50,000 songs every month, and our traction shows that that actually works and that people trust the system, which also, is important. The more features you roll out in the future, that you establish trust over time, and that's not just something that you use like ChatGPT and then your trust curve kind of dips after a while. So what we see is actually the opposite, that the more people use the system, the more they start trusting the system, which is a very good indication for us that this works. And then one other cool thing we were able to do was this thing, which we launched, I think, last year or something. This is the industry's first clone, or whatever marketing term you want to call it, of a Grammy-winning engineer. And again, the usual approach would be, okay, let's go through his catalog, train a system, and hope that the system understands how he engineers music. In our case, all we had to do was add more of those score functions that mimic how he perceives music, and then let the system run on those functions. And now we have a system that mimics more how he evaluates music and how he engineers music. So as said earlier, this is our technological solution to a problem in the industry that was very prominent recently. You probably heard all the headlines that especially Suno, the big AI companies that do prompt engineering, are now being sued for using material without permission. Obviously, for them, it was also a bit easier to get access to the data because they don't require high quality data, right? If you just want to prompt the final audio output, you're fine with, I don't know, scraping Spotify and getting a shitty MP3. In our case, for audio quality, you need raw data. So even if we wanted to, we couldn't just scrape the internet and find high quality data because that material is behind closed doors. But yeah, they're obviously now in huge legal battles. They raised a ton of money, and a lot of that is going into legal costs. And we can just sit back and watch what happens and essentially not be affected by this. Of course, we also got tons of mail from all the major labels in our inbox over there. They sent us letters saying, you dare not to use our data in your models. But we don't have to care because we don't. So yeah, that was kind of the run through of how we built the system. And if you have any questions, please ask away.
I have a question. Sorry, bro.
Oh, good.
When you said, the last thing you said was, we don't have to reply them. So you don't have to reply the labels. Because you don't use their data. Could you expand more on that? What you mean by you don't use their data?
Yeah, so we don't. So in the case of Suno, for example, right? So they had an idea of, okay, I want to build a image generator for music, so to speak. So we prompt something and then it spits out some music. Obviously, it needs a lot of examples, right? And so what they probably did, I'm just assuming, similar to all the other big model builders, they just went online and scraped the internet for audio files. And a huge chunk of that data is obviously label artists like Taylor Swift, Katy Perry, who have their music all over the internet. And now the labels, because if you prompt, I don't know, write me a Katy Perry style song, and you get something that sounds very familiar, the labels are assuming that they must have used training data that infringes copyright based on their argumentation, because otherwise the model wouldn't be able to output that song that sounds so familiar to, I don't know, Taylor Swift, for example. And in our case, we never even scraped the internet, right? We literally built the whole system with, I don't know, 10 to 20 songs we got from friends or beats we built ourselves just to find out, okay, what are those criteria we need to mathematically encode, and then the system could run on any data, right? It doesn't have to be catalog data. It can be noise, right? Just to understand how the scores map. If that makes sense? Does that answer your question, or did I wander off?
Yeah, if I got you correctly, basically you built your own music and then trained your models on those, like the music.
Partially, yes. Or we just use music that we got permission from, right? Like, so I called a few of my buddies who produce music, and I said, "Oh, do you have a hip hop track I can use for this to, try to build these functions?" And they said, "Yeah, sure, just go ahead." No legal process whatsoever.
They won't sue you, right?
Not
Yeah,
yet.
fine.
Depends on our exit, I guess.
All right, that's cool, thanks.
Before we do more questions, I need to be a little bit attentive on time. So I'll pick my own question. That's the next question, which is, how many songs have you guys mastered so far?
We just crossed 350,000.